Today we are going to discuss upon unified modeling language. When we say about object-oriented software development, unified modeling language is of a great use with respect to illustrating the system in terms of the modeling disciplines. Because this is a complex system, each and every system needs to be modeled before going for the actual development, which will aid the software developers to have a better understanding over the system and to get to know about what they need to achieve in terms of the completion of the product. So as a result of it, the unified modeling language becomes pretty important for the developers to learn well in advance and to get engaged themselves in terms of the actual software development or real-time software development practices. So as it is stated here, the UML is a modeling language and it is used to visualize the way how does a system is going to behave or how the system is going to react in the future. So in order to have a better understanding of the system, we need to go for creating blueprints of the system. So UML is going to serve for the purpose. And actually, if you look out into the UML, it is not a programming language, it is a design-based language. That is a modeling language which is used for visualizing the artifacts of the given system. And this UML has got two different categories of diagrams. Well, while we are going for learning about the UML, mostly we'll learn about these diagrams only. They fall under the structural and behavioral aspects of a given system. So what we call it as a structural aspect is nothing but how does the system is configured, how does an application is defined, and what are the different things to include in the actual system built, so that in the future we can go for developing, or in the future we can go for establishing certain functionalities over the given system based upon the definition what we had right over here. So those entire set of things are captured in terms of the structural aspects of a given system. And when it comes to the behavioral aspects of the given system, every system is capable of performing some kind of functionality. So that is captured in terms of the behavioral diagrams. So here we are just going to look out into several categories of diagrams or types of diagrams which are going to aid in the purpose. And we got certain a few set of details with respect to the UML in terms of the introductory aspects, what every learners should have a knowledge about it, from where it has originated. So as it was given here, it is originated from three set of categories of people who are into the actual software development environment: the software engineers, businessmen, and system architect. And it was developed by the object management group, which we otherwise call as the OMG. And that is the body which is going to give us the give the final go for the particular product. And it is being managed by the OMG, and several versions of the UML has come so far. And what we are going to learn in the classes to come is nothing but the most recent version. And when it comes to the actual set of things that we need to learn in terms of the diagram, it start as I informed you earlier, it start with the structural diagrams. So structural diagrams are going to capture the structural aspects of a given system or the formation aspects of the given system. So a few set of diagrams comes under this particular category, called the class diagram, the object diagram, the component diagram, and the deployment diagram. We'll see about this diagram in detail in the later stages of this presentation. And behavioral diagram, we have a much more a collection of diagrams, but the behavioral diagrams, as it is mentioned here, is used to capture the behavioral aspects of the given system. That is the dynamic aspects of the given system. So every system, as I told you, it is going to perform some kind of functionality, and behavioral diagram is going to capture all these functional aspects. So the diagrams which falls under the behavioral diagrams are the use case diagram, the state transition diagram, the activity diagram, and the interaction diagram. So these are the most dynamic diagrams, or the diagrams which are going to capture the dynamic aspects of a given system. And we'll straightly go into the diagrams. So this is a broader view of a layout view of how does the diagrams are categorized here. So coming into the class diagram, this is used to capture the categorization of each and every artifacts of the given system or entities of the given system. As we know very well, every system is built with objects, and all these objects definitely falls under some kind of categorizations. It is this categorization we call them as the classes. So while you are going to tell about a class diagram, it is going to possess the most common representations